watching Nama channel.
So now we see division algorithm of polynomial. Already write this. If p of x and g of x are any two polynomial, we have to take any two polynomial with the g of x is always not equal to 0. Then we can find the polynomial q of x and r of x. Q of x and r of x is nothing but quotient and remainder, such that p of x is equal to, we multiple with the g of x and q of x. First we multiple g of x and q of x and add it with the remainder r of x. We get p of x. In this case, r of x equal to 0, or degree of r of x is always less than degree of g of x. So next we have to see the example 6, 7, 8 and 9 on the basis of this degree division algorithm of polynomial. Okay, now we see the example 6. Divide 2x square plus 3x plus 1 by x plus 2. Already I informed in division algorithm, we take two polynomial like p of x and g of x. So I take p of x is equal to 2x square plus 3x plus 1, and then g of x is equal to x plus 2. First of all, we have to divide p of x, divide g of x on the same normal method. I take the polynomial 2x square plus 2x square plus 3x plus 1. So I take division by x plus 2. I will take the first term of this p of x and then first term of g of x. So 2x square can be divided by x. So we get 2x. So we multiple with 2x. 2 into 1, 2, x into x, x square, plus into plus, plus 2 2s are 4x. So next we want to change the symbol. So plus become minus and then plus become minus. So plus 2x square minus 2x square, it get 0. And then here what you see, minus 4 and then plus 3 with the same variable. So like terms only we have to add and subtract. So because of that, plus 4, minus 4 and then plus 3. Here 4 is bigger one, we take minus. So 4 minus 3, 1. You no need to put 1. So x plus 1. As usual, the same method, minus x divided by x, we get minus 1. So we multiple with minus 1. So 2x minus 1. So 1 into x, that means minus x, minus 1 into plus 2, minus 2. Again, as usual method, we have to change the symbol. Minus x plus x, we get 0. So plus 2 plus 1, we get plus 3. So already I told quotient is the q of x and then remainder is r of x. Here q of x, which is equal to 2x minus 1, and then r of x is equal to 3. So this is normal method. We have to divide the two polynomials. So 2x square plus 3x plus 1 can be divided by x plus 2. We get quotient and remainder like this. Next we move on to the example square. So I will take the first term p of x, 3x cube plus x square plus 2x plus 5. So here the polynomial in the same order, 3, 2, 1 and then 0 is in order. But second, 1 plus 2x plus x square. So I have to make this order first. X square, 2x plus 1. So as usual method, again we take the as usual division method. X square plus 2x plus 1, 3x cube plus x square plus 2x plus 5. So first term can be, we multiple through 3x cube divided by x square, we get 3x. The first quotient is 3x. So x into x, x square, x cube. So 3 into 1, 3x cube. As well as plus into plus, plus 3 2s are 6, x square. And then plus into plus, plus 3x. And after that I have to change the symbol by using the different. So minus and plus become minus, and plus 1 become minus. like this, same number with a different symbol, it could cancel. So minus 6 plus 1, so there is no coefficient, 1 is the coefficient. So minus 6 plus 1, we get minus 5 x square. The same way, minus 3 plus 2, we get minus x. And next we take the third term, plus 5. We compare the first two terms. Minus 5 x square divided by x square. X square make it cancel, minus 5. So we take minus 5. So minus into plus, minus 5 x square, minus into plus, minus 5 2s are 10x, minus into plus, minus 5. Now again we change the symbol. Minus become plus, minus become plus, minus become plus. Now already you know that it will cancel. So plus 10 minus 1. So we get 9x. Plus 5 and then plus 5. Plus 10. So here what is the quotient and what is the remainder? Which implies that q of x is nothing but 3x minus 5. And then r of x is nothing but 9x plus 10. So in these two examples, just we have to divide only. So 8th question, we have to divide and we have to verify the division algorithm, like p of x equal to g of x into q of x plus r of x. Now we see example 8, divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square, and also we have to verify the division algorithm. So I take the first one is p of x, 3x square minus x cube, so the degree is in alter. So because of that I make an arrangement, minus x cube plus 3x square minus 3x plus 5, as well as x minus 1 minus x square, again I rearrange this, minus x square plus x minus 1. So now the normal method, we have to do this, divide the polynomial. Minus x cube plus 3x square minus 3x plus 5. This one can be divided by minus x square plus x minus 1. We compare the first term. Minus x cube can be divisible by minus x square, minus will get cancelled. Then x square remaining x. So first plus x, plus into minus, minus x cube, plus into plus x square, plus into minus, minus x. So now we change the symbol. Minus become plus, plus 1 become minus, and then minus become plus. So now minus x cube plus x cube will get cancelled. 3x square, that means plus 3 and then minus 1. So 3 minus 1, 2x square. And then minus 3 plus 1, we get minus 2x. So remaining one number is there, plus 5. Again we compare the first term. 2x square can be divisible by minus x square will get cancelled, we get minus 2. So minus into minus, plus 2x square, minus into plus, minus 2 into x, 2x. Minus into minus, plus 2 ones are 2. Now we change the symbol. Plus 1 become minus, minus become plus, and plus 1 become minus. Now we compare the symbol. It will cancel. Plus 2x and then minus 2x, it will cancel. So it is the remaining 1 plus 5 and then minus 2. It become plus 3. So we get q of x equal to x minus 2 and then r of x which is equal to 3. We find out the quotient and remainder. Next we have to verify the division algorithm. So I write this quotient and remainder here. So Q of x we find out x minus 2, and R of x we find out is 3. Now verification. So what is the division algorithm? P of x is equal to G of x into Q of x plus R of x. The same way, what is G of x? Minus x square plus x minus 1. This one can be multiplied with the Q of x, x minus 2, and this total product can be added with the R of x 3. So now we multiply the whole term with the first one. So x square into x, it should be minus x cube, and then x into x plus x square minus 1 into x minus x, and then we multiply with the second term, minus x into minus 2 plus 2x square, and then plus x into minus 2 minus 2x, minus into minus, minus 1 into minus 2 plus 2, and finally we take this plus 3. So now we compare minus x cube, here plus x square plus 2x square, we get plus 3x square. Here minus x minus 2x, we get minus 3x. So 2 plus 3 plus 5. So now you see minus x cube plus 3x square minus 3x plus 5. Now we verify which is equal to P of x. Therefore P of x, which is equal to G of x into Q of x plus R of x. Next we move on to example 9. Now we see example 9. Find all the zeros of 2x power 4 minus 3x square minus 3x square plus 6x minus 2. If you know that 2 of its zeros are plus root 2 and minus root 2. In this previous exercise we see that how to find the zeros. So here the degree of this expression is 4. So we need 4 roots. Here 2 roots they are given. So in solution, since the two roots are plus root 2 and minus root 2, this one can be therefore, which implies x plus root 2, x minus root 2 are factor for P of x, which is equal to 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. So x plus root 2, x minus root 2. So a plus b, a might be in the formula. A plus b, a minus b equal to a square minus b square. Because of that, x square minus root 2 the whole square, which is equal to x square minus 2. So x square minus 2 is the, we take it as now g of x, which is equal to x square minus 2. So we have to divide 2x power 4 minus 3x cube minus 3x square plus 6x minus 2 by x square minus 2 to find other two zeros. Minus 2, normal division, x square minus 2. The same way, the first step, 2x power 4 can be divided by x square, we get 2x square. So here 2x square. So 2x square into x square, x power 4. And then plus into minus, minus 2 2s are 4 x square. So here you have to see x cube is there, but here x square. So what is the confusion? So x square is not there, so we leave it here. It become 0. So plus into minus, minus 4 x square. Now the normal way we have to change the symbol. Plus 1 become minus, minus, and then plus. So it become cancelled. Minus 3 x cube plus x square. We take the another term plus 6x. Now we compare this term. Minus 3 x cube divided by x square. We get minus 3x. So plus into minus, minus 3x cube. Next we move on to x term only. So x square is not there. We put 0. And then minus into minus plus 6x. Now we change the symbol. Plus, minus, minus. This one and this one we get 0. Finally we get x square minus 2. X square minus 2. X square divided by x square 1. So plus 1. So 1 into x square minus 2. X square minus 2 becomes 0. So now we get a remainder is 0. But q of x, it become again quadratic equation. We have to split this equation to find the remaining zeros. Already we know that 2 zeros plus root 2 and then minus root 2. We have to factorize this q of x. Again we have to factorize this q of x to get remaining 2 zeros. So we get q of x, which is equal to 2x square minus 3x plus 1. So we have to split this middle term to factorize to get remaining two factors. So first we take plus 2 and then minus 3. So I have to multiply this 1 into 2 minus 1 minus 2. So minus into minus equal to plus 2 and then minus 1 minus 2 we get minus 3. Which implies that 2x square minus 3x plus 1 can be written in the form 2x square minus 2x minus x plus 1. So here I have to take 2x is common, remaining x minus 1. Here minus 1 is common, x minus 1. So x minus 1 and 2x minus 1 is the zeros. Factors for 2x square minus 3x. So this is the factor for 2x square minus 3x plus 1. This one can, which implies that x minus 1 equal to 0, x equal to 1, as well as 2x minus 1 equal to 0, 2x equal to 1, and then x equal to 1 by 2. So already we have plus root 2 and minus root 2 are zeros of p of x. Here 1 and 2. Therefore, zeros of the polynomial p of x are plus root 2, comma minus root 2, comma 1 and 1 by 2. These are the 4 zeros of the polynomial.
Thank you for watching நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா லைக் பண்ணுங்க, கமெண்ட் பண்ணுங்க, ஷேர் பண்ணுங்க. வீடியோ